This video is going to cover how to add and subtract polynomials. So we have a couple things with these. We're going to talk about degrees of monomials, classifying polynomials, adding and subtracting, and then eventually some real life problems we'll cover over time. All right, so a monomial, right, by definition is a number or variable product of a number and one or more variables with whole number exponents, okay? So here's a monomial. Now the key here is it has to have an exponent. The exponent in this case is 0. So this is 10, and then there's an x here to the 0 power. 3 to the x. Well, what exponent does x have? In this case, x has a power of 1. In this case, a has a power of 1, b has a power of 2, so it ends up being a degree of 3. All right, down here, m has a power of 5, and so that's going to have a degree of 5. Here are various examples of non-monomials and reasons why. So again, the key thing is it's going to have a whole number and it's going to have an exponent with it. And so here are some things. So this is called a monomial. It's a number, variable, or product of a number. Okay? All right, so here's some monomials here. In this case, we look at the variable and it has a power of 2, and so the exponent is 2, and so the degree is 2. Right? Over here, x is 1, y is 3. All right, so the degree of this thing is 1 plus 3, which is 4. All right, over there we have 3 and 3 for x and y, so that would be 6. And then over there, that would be 0 because there's no variable, and so that would be a monomial of power 0. Degree 0. All right, so a polynomial is a bunch of monomials linked together, right? So a polynomial with 2 terms is what they call a binomial. And then we also have what's called a trinomial. So here's an example of a binomial. We have 5x plus 2. There's 2 different terms here of different degrees. Over here, here's a trinomial where we have 3 different terms of different degrees. Okay, so the degree of a polynomial now is the greatest degree of its terms. So in this case, this would be a degree of 1. This would be a degree of 2. Okay. In standard form now, they're going to ask you to do things in standard form. We write them, the exponents go from the left to the right. They go greatest to least, left to right. All right, so that is the key. And then the leading coefficient here. So in this case, the coefficient's 5, the coefficient's 1, the coefficient's 5. So you do the powers first, right? And then you have the coefficients that go with them, whether they're positive or negative. Now, if you have a degree of 0 here, this is what we call a constant, and that always goes at the end. Now, there are examples when some of these degrees won't be there at all, but you still go greatest degree to the least, even if some are skipped or missing in the particular problem. All right, so in this case we have here, so we look at degrees first, and we want the 3rd degree first, but the negative has to go with it. This would be second, and that would be positive, and then we have the constant here, which is 3, okay? So the degree is, where are we at here? Yes, here we go. So in standard form, we do negative x cubed plus 15x plus 3, okay? All right, now, how do we add these up? When we add polynomials, this is just a fancy way of saying combining like terms. So we want to find, in this case, we have 2x to the thirds, right? 2x to the thirds. Where else do we see x to the thirds? Well, we see 1 right there, and there's 1 here. So we have 2 here plus 1 there, and that gives us a total of 3, okay? And so there's a couple ways that you can do this. Right? There's a horizontal and a vertical. So if you understand that we're combining like terms, we can also do this in a vertical format or a horizontal format. So what they did here is we rewrote this first expression here, greatest power to least, okay? And then we rewrote the second one, greatest to least. And notice how the order switched, and notice how there's the x term here is missing because there is no x term in this second expression. All right, so we have 2 plus 1 gives us 3. Negative 5 plus 2 gives us a negative 3x squared. X just becomes x, and then the constant there at the end is this negative 1. All right, so that would be a vertical way to do it, right? Now, you could also do it horizontally. So if we look at this example, we'll go horizontal. This is more of your combining like terms that we're used to. So we have 3x squared and we have 1x squared. That gives us 4x squareds, right? And we would combine that into 4x squared. We have a positive x and a positive 4x. So to kind of show the work, they did that. Negative 6 minus 10 gives us a negative 16. Okay. All right, now for subtracting, we can do the same thing vertically and horizontally. Now here's the big one. When we subtract, we have to pay attention to the expression we are subtracting, because all of these signs have to switch. Anytime we see a negative sign, it's the opposite of that particular term. Okay, so let's take a look here. So we have in vertical format, we have 4n squareds, we have no n's, so that's skipped, and then we have the constant 5. So what is the opposite of negative 2? That's going to give us a positive 2, okay? The 2n, what is the opposite of 2n? That makes it negative n. What's the opposite of negative 4? That makes it positive 4. Now we can in this case add, and we get 6n squared minus 2n plus 9 in that case. All right, so if we go horizontally, in this case here, we have to make sure we're taking care of that negative sign with each of those terms. So remember, this negative sign means the opposite of, and then whatever's in the parentheses. So we have 4x squares here, and we have, which is going to end up being negative 3x's here, because it's the opposite of 3x. So that's going to give us a positive 1 for our x squares. We have negative 3x here, and when we do the opposite of a negative x, that gives us a positive x. So we have 3 negatives and 1 positive, and that's going to give us 2 negatives. We have 5 positives, and then this is going to be 8 positives, negative 5 and negative 8. Sorry, the opposite of negative 8 is a positive 8, and that gives us 13. Okay, and then it's in order from greatest to least. All right. So hopefully that makes sense. If there's parts of the video that you didn't understand, just go back, watch it slowly, go through the steps and the examples, and see if you can't make sense of it. This is a pretty easy skill to learn, but it is crucial because you're going to be using this over and over and over again between now and the end of your math career.